Hello guys, welcome back to MedZone African Motives. Still working on power machines and 5 revisions. Here we've got a question that we are going to consider about boilers, in this case, boiler calculations, so that we'll see how are we supposed to attempt such typical questions. We had a similar question, but just different. The one that we had, it was having a superheater. From water to a superheater direct. That was the diagram that we were given, if you still remember. Now we are given information. Let us read together and construct what we are supposed to have here. 2.1, we have got a condition that we have from this part that a steam boiler plant supplies 5,200 kgs of wet steam at a pressure of 780 kilopascal every hour. All right, we are talking about the wet steam that is at the output of our boiler in this case, like I explained before, that you'll be having, on a normal condition, you are supposed to have an economizer, an evaporator, superheater, but here we are going straight to the boiler. We are not considering the economizer. So that is what is happening here, whereby we are having our evaporator, or the boiler. In this case, we've got our evaporator, that's OU, evaporator there. All right, or we are considering it as a boiler in this case, or just gonna consider this as a boiler. All right, so that is what we have there. So if we are to take note, they are giving us the wet steam, the mass of the wet steam, which means after the evaporator, that is where we are going to have our wet steam. So there we've got the mass of steam being considered as 5,200 kilograms per hour. So we've got 5,200 kilograms, which is taken per each hour. And also we are given here that at a pressure, meaning to say the pressure at the boiler in this case is 780. So here we have got a pressure of 780 kilopascal. All right, so we're going to indicate our pressure of 780 kilopascal in this case. All right, then the steam is 2% wet. So from the 2% there, we're going to have our dryness fraction, which is going to be 100% minus the percentage when it is wet. In this case, we have got 100% minus the percentage wet, which is 2% wet in this case. So that means it is going to remain as 98% dry in this case, which is 0.98. So there, they have given us the dryness fraction, which affects definitely after the boiler. In this case, at the boiler, we've got our dryness fraction of 0.98. And what else do we have? And the feed water temperature is, we're talking about the feed water now. This is our water at the entrance. That's where we have our water. So we are given the temperature there. If we check, sometimes they might not give you this temperature, but here we are given. So this is our TS or T1, which is 40.3 degrees Celsius. All right, so we've got 40.3 here, degrees Celsius. So we only have two parts of the diagram, the first part and the second part here. So meaning to say here we can write it even as T1, which is fine. TS, that is for the saturated temperature. Then the boiler uses 660 kgs of fuel to supply 5,200 kgs of steam, which is this one, 5,200. So we are going to need the fuel of 680 in this case. So the mass of fuel is going to be 660. That was 60 there, kilograms per hour. All right, so that's it. We also given, and the fuel has a heat value of, which is the calorific value or the heat value of 30 megajoules per kg. Since these values are given in kilograms per hour, and also sorry, not here, but if you are to check, when you are to calculate our H here for the boiler, and also the H, the enter for the water in this case, which is HF or H1, they are going to be in kilojoules per watt per kg. So it is best for us to also have this in kilojoules per kg. So that's, we're going to have it as 30,000 kilojoules. We're going to have 1,000 there times 10 to the exponent of 3 to get that mega. So it will be 30,000. In this case, we're going to have this as 30,000 kilojoule per watt per kg of the fuel. So that is it there. Then the question is, with this information that we have, the question was to calculate the boiler efficiency. 7 marks, and you'll be wondering, where are we having the 7 marks? The 7 marks there, we have considered the part of this diagram that we are having. All right, in a normal sense, the boiler efficiency was supposed to be, if you're dealing with two things like this, you just have to consider the enthalpy at the end and the one at the beginning, which is H1 minus H2. The formula we're supposed to have from our formula sheet was supposed to be mass of steam into H2 minus H1 over the mass of fuel, in this case, times the calorific value times 100%, all right? Whereby here we are simply referring to HF. H1 is our HF in this case. So this is our HF. Then H2, when we have got a dryness fraction, this is our H wet. Remember, the steam here was wet. So here we are considering H wet. So this is our H wet in this case, which means how are we going to have these? Because we have got everything, this one, everything there we have, but we do not have these enthalpies. That is for the water and for the steam, considering our dryness fraction of what? 0.98. All right, so meaning to say for HF here is direct, we're gonna just use our steam table because we've got temperature. Remember last time I said if there is pressure, sometimes they give you pressure here, you use the pressure at the inlet. We use the pressure at the inlet. Okay, here we are going to use the pressure that we are given. Was already have the pressure there, but here we do not have the pressure at the inlet. We've got the temperature at the inlet. So on your steam table, we are going to consider this on our steam table. The temperature there, remember, it's 40.3. So under the temperature TS, which is our saturated temperature, 40.3, that is at 40.3. If you are given pressure, you're going to use pressure, meaning to say under temperature in degrees Celsius here is 40.3. So meaning to say, if it was pressure, they were going to give us a pressure of what? 7.5 kilopascal, but here they gave us what? This temperature. So under this temperature, we want the equivalent value that is going to correspond to HF. We are going to consider this whole part here of what? Of our HF, which is of our temperature of 40.3. So under this HF, which is the one that we need, which is our H1 in this case, our HF there is 169 down here. We are having 169 kilojoule per watt per kg. These are the units that we are given. So that's, we've got the value of HF from there. So let us write our HF. We said this is going to be 169. So we've got 169 kilojoule per watt per kg. All right, in order for us to obtain H wet, in this case, we do not have this direct from our steam table. We are supposed to make calculations there. They were supposed to make calculations. All right, remember this was 2.21. So on H wet, we are supposed to make calculations. How are we going to obtain H wet? Remember, H wet is equivalent to HF plus X HFG. So that is how we calculate our H wet, which is our H2 in this case, this one. So by doing this, we are supposed to obtain a pressure that we are going to use to obtain HFG and also HF there, which is the pressure that we are given at what? At 780 kilopascal. So what is the value of HF there? What is the value of HFG there? So that is it, our HF at 780. So we need pressure this time. So we're going to consider pressure at 780. So as you can see here, under pressure 780, we are still below 780. So let's move on to the other page. If we check on this page here, that is where we're going to obtain 780 at this point under the pressure in kilopascal. 780, it's here. So we are going to consider these values that are under 780. All right, so let's just hope I'm not going to affect this. All right, sorry for that. So this is what we are going to consider under 780 kilopascal on your pressure. What do we need in this case? Remember, we need HF there and HFG. So our HF, which is 717 kilojoules per kg, our HFG, which is 2050, which is in kilojoule per kg. So these are the values that you're going to take: HF, this one, HFG, this one. All right, so I'm going to take these values here. All right, remember our values, guys. We obtained HF here, which was 717 kilojoule per kg, sorry. Then HFG, which was 2050 kilojoule per kg also. All right, so that is it. We're gonna substitute to calculate our H wet in this case, and this value for H wet is going to be HF, which is our HF. We got our HF here, 717 plus X, which is the dryness fraction of 0.98. So we've got 0.98, sorry, that's 0.98 times HFG in this case, which is 2050. All right, so that was it. We were going to obtain H wet in this case, of which our H wet was going to be 2,726, 2,726, which is in kilojoule per watt per kg. So like I was saying, these values, they are in kilojoule per kg. That's, we are going to need our calorific value here on our calculation for the efficiency in kilojoule also per kg. So we have everything. Now we're going to substitute mass of steam. We've got the mass of steam per hour, which is 5,200 into H2, which is our H wet in this case. Our H wet here is 2,726 minus H1, which is our HF of 169. All right, so that is 169, everything over. So here we are going to consider the mass of fuel, which is 660 times the calorific value in kilojoules per kg, which is 30,000. So that was 30,000 times 100%. So that's it. We have got the efficiency of the boiler in this case. So consider if we are given, sometimes they are given in part of Economizer, you use the last H to the first H. So if it is H3 minus H1, here we've got H2 minus H1. So that's how we will play around there on the efficiency. All right. So that was going to give us an efficiency of the boiler in this case, sorry for that, which is which was going to be 67. So this was going to be 67,1535, which is 154%. All right. So that is the condition that we were having for this question. So as you can see, 7 marks, actually it required 7 marks because there we needed to calculate H wet, to have HF, and also the illustration of information is important. All right, then from there, the equivalent evaporation, and it must be at what? 100 degrees Celsius. Always the equivalent evaporation, you are going to take it at what? 100 degrees Celsius. All right, so from our formula, this time we are going to consider our equivalent evaporation as, so this is 2.12. All right, so remember that the equivalent evaporation at 100 degrees Celsius is given as mass of steam. We are supposed to use H2 minus H1 in this case, H2 minus H1, which is, remember, our H2 is H wet according to our diagram, and this is our HF. All right, over the mass of fuel times 2,257. All right, so that is the formula that we are supposed to obtain since we are dealing with only 2 parts of the boiler, H2 and H1. So the mass of steam, mass of fuel, everything, as you can see, we calculated this. We have got mass of fuel, mass of steam, 5,200 and so forth. All these values we have. So this is going to be 5,200 into, or you can just have a bracket there instead of doing this. Let's just have a bracket. H2 minus H1. It's just a repetition of what we did here. 2,000. So this part as it is. So we're just going to have a repetition there. So remember, our H2 was 2,726 minus H1 which was at 169. Everything over the mass of fuel. Again, we have the mass of fuel. We used it before here. Mass of fuel, which was 660. So that was 660 kilograms per hour. So we are going to have 660 times 2,257. All right, so that's our equivalent evaporation of which is going to give us 8,926034, which is 926. So that is given as per kg steam. We're gonna have this per kg steam as kg steam per kg fuel in this case. All right, it will be kilogram steam, kilogram steam for the for any required kg of what of the fuel that is needed. So that's it. That's how we play around these questions. You just have to be careful on playing around with these typical questions. Now, if we consider this question, it was a tricky part, but let's see, 10 marks for that. Let's see what are they trying to say here. They are saying an economizer is installed. Take note. There is an economizer which was being installed, and the feed water temperature in question 2.1 is increased to 28.8 degrees Celsius. All right. So we had remember what I was saying before, that in actual sense, we are supposed to have an economizer, all right, on the first place here, economizer to the what? To the boiler in this case. So they are saying we constructed, or we had an economizer this time, so that this temperature at the inlet, instead of being 40.3, now it's increased by 28.8 degrees Celsius, meaning to say it is going to affect the inlet temperature at the input because it's being increased. So we are going to consider our T1 this time as 40.3 plus 28.8 because we have increased by 28. And the efficiency of the boiler increases by, meaning to say that efficiency that you calculated was going to change. And all other conditions remain the same. So everything is going to remain the same, but these two are going to be increased. Now they are saying calculate the mass of fuel saved per every hour, the mass of fuel saved. So in order for you to have the mass of fuel saved, you are supposed to consider calculating the mass of fuel again with these conditions, because before we have the mass of fuel here, this is our mass of fuel at what? At 660 kilogram per hour. So let me explain this way. Since we want the mass of fuel saved in this case, remember that is our question. We are going to need the mass of fuel that is being what? Saved. So we are going to consider previously what was the original mass of fuel. The original mass of fuel at these conditions is given as 660 kilogram per hour. So that was 660 kilogram per hour in this case. This is the mass of fuel that we are given. And now we are considering a condition that the temperature is going to change as we considered T1 in this case, to say at the input T1 in the economizer is going to be 40.3 plus 28.8, which is going to give us 69.1 degrees Celsius. So we now have the input temperature at the inlet, at the economizer. The temperature there is now 69.1 degrees Celsius. So what is it that we are going to do from this? This temperature is going to affect our H. Remember, from this temperature, we've got H1, which is our HF. So it is going to affect this enthalpy is going to be affected because remember this HF, we took it at 40.3. So we are going to need it at this temperature of 60.9. So we are going back to our steam table again and check for what? A condition of our temperature being at 69.9 in the 69.1 degrees in this case. And if we check under temperature, because this is your temperature in this case, this is our temperature here, and this is our HF going down here. We are going to consider this HF going down under this temperature in this case. All right, so let's consider that down under the temperature of 69.1. So if we are to see here, 69.1, that is down here, 69.1, that's somewhere here. So I want you to see we are still under the temperature. Remember, this is our temperature here. We are still under the temperature here. So we need 69.1, which is this temperature here at 69.1. What is going to be the corresponding value of HF there? This is the column of HF. So HF at this value is going to be 289. So meaning to say we are now considering our H1 or our HF in this case as 289. So this is going to be 289 kilojoule per watt per kg. All right, so this is from the information that you are given that changed. This one changed, so it's going to change this, but the rest, they are remaining as they are. So the question needs us to calculate the mass of fuel which was saved in this case, meaning to say we are going to calculate the other mass of fuel with these conditions. Then we see the difference that is going to happen between the mass of fuel that we had before this one and the mass of fuel that we are going to have under the new conditions, because now we are dealing with these new conditions. And what are the new conditions? Is the temperature that has increased. And also let's consider there's another condition here. Okay, I left another condition here. The efficiency, the efficiency of the boiler increases by 7.5. So there's an increase in efficiency in this case. All right, so also there's an increase or the change in efficiency, which was 7.25%. There's a 7.25%. This is from our efficiency, 7.25%, which is an increase. So an increase you are supposed to add whenever you are dealing with an increase. You are supposed to what to add. They might say it's a decrease. So if it is a decrease, you subtract. So this one we are going to add to the original. If just like our temperature, we added to the original temperature T1 where it was affected. Here we affected this efficiency here. Remember our efficiency before, it was 67.154. All right, so we are going to affect this to find the new efficiency at new conditions here. So at new conditions, we are going to have our efficiency, since it increased by this from the original of 67.154. That was the original efficiency. We are going to increase to add 7.25%. So that was going to give us the efficiency of the new condition, in this case as 74.404%. So this is our new efficiency in this case, and we have got the new temperature for the input of water at the economizer. So the question is, how are we going to have the mass of fuel from these conditions? As you can see, since we are given the efficiency here of the boiler or of the system, we can play around with this, because we understand that from the efficiency formula, if you check from that formula that we considered, we had mass of fuel. Remember, they are said all others, they remained the same. All right, the efficiency, we calculated it as the mass of steam. In this case, remember our calculation, it was the mass of steam into H2 minus H1. Then we're gonna consider the mass of fuel times the calorific value, in this case times 100%. So meaning to say, what we are going to do is to have everything considered on our information so that we can calculate the mass of fuel at these conditions. We want to determine this because we have this originally, so we want to determine at this condition what is going to be our value. All right, the efficiency 74 points. So if we divide by this 100%, we are going to obtain a decimal there of 0.74404, which is equal to, in this case, remember the mass of steam in this case is not going to change. They said everything remains as it was in this case here, remember, and all other conditions remain the same. So meaning to say the mass of steam is not affected, 5,200 kilograms. So we still have 5,200 there kilograms per hour. All right, so there we've got 5,200 into H2. Also, H2 is not affected at the outlet our H2 is not affected here, which was in this case H wet. Remember our H2 2,768. So this one is not gonna affect. So remember it was 2,726. Sorry, 2,726 minus H1. H1 is the one that was affected because of T1, the temperature there at the economizer. It's now 69.1. So it affects also H1, which is now 289. So this is the change that happened here. On the enthalpy, on the efficiency, it changed also. So we are going to calculate with these conditions, we are going to calculate the mass of the fuel. All right, so that is it. The calorific value, remember in kilojoules, we had our calorific value of 30,000 in this case. So that was at what? At 30,000. So that was the whole part of our question, to calculate the mass of fuel from these conditions that we are given. Then we relate back to the one that we had before. All right, so here, what we can do is to cross multiply. Yes, this simple equation. Let's just work our simple equation. Cross multiply this whole part here and this whole. So this is going to multiply this number of 30,000, which is going to be 22321,2 times the mass of fuel, which is equal to 1, multiplies this. So the bracket is going to expand everything here, or just leave it like that. If you do not want to expand with the bracket, just leave it as 5,200 into 2726 minus 289. All right, so to find the mass of fuel, you're going to divide this side by 22321,2. All right, divide also this side 22,321,2. So this was going to cancel. We have got the mass of fuel in this case at the new conditions. All right, so this is our mass of fuel, which was going to be 567.729. Remember the mass of fuel from the mass of steam, which is in kilograms per hour. So this is also going to be in kilograms per what? Per hour. So this is when our conditions had changed, or at new conditions, we are obtaining this mass. As you can see, it's a little bit lower from the one that we had before. Before, our mass in this case was at 660 kilograms per hour. So meaning to say we are going to subtract now the difference, 660 minus the one that we obtained now, because the question needs us to calculate the fuel that was being saved. So the fuel that was being saved is simply from this mass that we are having between the two. So that is the mass of fuel saved in this case is going to be what? The one that we had in the original part of 660 kilograms per hour minus the new mass of fuel of 567.729 in kilograms per hour. So this was going to give us 92.271, which is kilograms per hour. So that is the fuel saved, the mass of fuel saved from these conditions. We are obtaining the mass of fuel that is being what? That is being saved. So guys, be careful when you are calculating the information, how it is given. Play around the information the way it is given. There you are given a new condition to consider when an economizer is being installed. As we understand from our normal approach, that if we have got an economizer, in this case, we are going to have economizer to the evaporator, but here we are given straight the boiler or the evaporator. So now we have got an economizer, which means our T1 is now at the inlet of the economizer. That's where we are going to have our T1, but it is being increased. You work with the condition, because it's not like you are going to have a similar question with these conditions that we are seeing here. No, we are going to have another question with other conditions. Maybe they are going to increase, decrease the efficiency. Maybe they are going to increase the temperature or the pressure for the boiler. You never know what's going to be increased there. You work with what you are given, but that is how you answer those typical questions. Just for the sake of revisions so that we understand. So that was actually 20 marks for everything. All you just need is to know your formulas properly and how to just have a sketch, of the information that you are given. From that sketch, it can help you to understand how are you answering your questions. It's very, very important to have that or to do that.